Okay, I think we can get started now. Hi everyone, and welcome to another Pegasus webinar. Today, we're going to take a look at private networks on Ethereum, especially how we can send private transactions in Besu and some of the new features that we have for our 1.4 version. Let me start introducing myself. My name is Lucas, and I've been working for Pegasus for a bit over 2 years now. I've been involved in many Ethereum projects in the ecosystem like Besu, Orion, EthSigner, and some of the client libraries as well. You might have seen me around on Rocket Chat or Gita answering some of your questions. Just a few friendly reminders before we begin. Please make sure that your microphone is muted throughout the presentation. If you have any questions, just throw it in the chat and we're gonna get to them during the presentation. We're gonna have a few moments that we're gonna stop to answer some of the questions in the chat. And also by the end, we're gonna have an opportunity for asking as many questions as you want. And as I'm presenting, don't worry too much about taking heaps of notes or memorizing everything that I'm saying, because this webinar is being recorded and it's going to be shared with you along with any extra material that's going to be important to get you guys started. So don't worry. This is our agenda for today. We're going to start looking at what is privacy and why people want to use it. And after that, we'll take a look at our implementation of privacy in Besu and a few important concepts there. We're going to see a demo of things working, which is always a good thing. And in the end, we're going to take a look at our roadmap on privacy, so you know what is around the corner for Besu. If you are here, I'm assuming that you heard about Pegasus before. We are the protocol engineering team at Consensus with a mission to advance adoption of Ethereum, especially by enterprises. We not only have a variety of products in the Ethereum ecosystem, but we also provide enterprise-grade support for customers. Hyperledger Besu is the most reliable Ethereum client out there. It started as a Pegasus open source project and was donated to Hyperledger Foundation last year. It was designed with enterprises in mind, from the friendly Apache 2 license that we decided to use, and also with the implementation language of choice, that is Java, makes it easier for enterprise adoption. It can be used not only as a regular public Ethereum mainnet client, but you can also use some of its enterprise features like permissioning or privacy. Okay, what is privacy? Privacy is all about the ability of sending private transactions. So it provides a way for a node to decide to send a transaction to a specific subset of the nodes in the network. If you're familiar with Ethereum, you know that all transactions in Ethereum are public and anyone can see the content of those transactions. With privacy, you have the option of selecting a few nodes in the network that are going to be able to see that transaction. So for example, if I'm deploying a smart contract, I can decide that that smart contract is only going to be visible by a few nodes. And only those nodes will be able to know about the existence of the contract. Only those nodes will be able to interact with that contract. And for everyone else that is not a participant on that transaction, they won't even know that the contract exists. It's all about interacting with other nodes without revealing the content of the interactions. That's the key thing here. I don't know how many of you heard of the Enterprise Ethereum Alliance, or as we call it, the EEA before. So the EEA is a group of companies that are working together to create this client specification for an enterprise Ethereum client. An enterprise Ethereum client can be seen as an extension of a regular public Ethereum client. So it's an Ethereum client that does everything that the public Ethereum client does, but adds on top of it some extra features that are really important for enterprises when using Ethereum. As you can imagine, private transactions is one of the most important features identified by this group, and it has been specified in the spec. One of the types of private transactions that have been defined in the spec is restricted private transactions. With restricted private transactions, the transactions that are going to be sent to only a specific number of participants. They are always encrypted, and they cannot be sent to anyone that is not a participant on that transaction. So you need to make sure that the content of this confidential information is only shared among trusted parties, right? Even though it's encrypted. There's a bunch of regulatory and compliance rules that enterprises are subject to sometimes. that forbid any confidential information for reaching non-trusted parties, even if it's encrypted. So we need a way of making sure that not only the information is encrypted, so the private transactions are encrypted, but they are also only sent to the right nodes, to the right participants. Well, that was like a really quick introduction. I don't know if anyone has any initial questions here. Grace, do you have anything on the chat?
Not at the moment. Let's give everyone a minute. If you do have any questions, ask them in the chat now. Looks like we're in the clear for now. Yep.
Okay, good.
Keep going, Lucas.
Awesome. So now that we know what private transactions are, let's take a look at how we have implemented them in Besu. I like to break this into three concepts, three core concepts, and they're really important. So first of all, as I've mentioned with restricted private transactions, we need a way to make sure that the transaction is going to reach the participants that it needs to reach. So that's what we call the off-chain transaction distribution process. And it's going to make, we're going to take a look at how we do it. The second important concept is the concept of privacy groups. Imagine a privacy group as a kind of mailing list. So you've got members to that mailing list. They are identified by an ID. So you have an ID for this privacy group. And when you are sending a private transaction, you can say that you send that private transaction to a privacy group. And then Besu is going to make sure that it's going to find the participant list on that privacy group, and that the private transaction is going to be sent to those participants. The third thing is the private transaction processing. So we're going to take a look at how we are using precompiled contracts to add the extra logic that we need to process private transaction, and more importantly, without breaking compatibility with public Ethereum. So you can still use your Besu node with private transactions in a public Ethereum network, for example, on mainnet. We're going to see how we did that. Okay, so the first one, the off-chain transaction distribution. You probably heard about Orion before. If you've been using privacy, you've heard about Orion, or if you haven't, you're going to take a look at it right now. So Orion is our implementation of what the EEA has defined as a private transaction manager. A private transaction manager has basically two responsibilities. One, it has to be able to encrypt the private transactions in a way that only the participants will be able to decrypt it. The second thing is that a private transaction manager must be able to distribute that private transaction in a way that it's only going to be sent to a specific list of participants. So for example, if you take a look at this diagram here, imagine that Alice has a privacy group with Bob and wants to send a transaction to Bob. So Alice is going to use Orion to make sure that only Bob's Orion is going to receive that private transaction. Lisa won't receive anything in this case. And Alice is going to use a combination of Bob's public keys to encrypt that transaction, and everything happens automatically. I won't get into the details of how Orion does it, but the important thing here is to understand that Orion fulfills that need for the secure channel that's going to be used by Besu to distribute the private transactions to the participants that are supposed to receive that private transaction. Orion runs as a separate service, and it all creates its own network of nodes. The usual deployment is something like, as you can see in this diagram here, where you have one Besu node paired with an Orion node. So they talk with each other, and each Orion node talks to the other Orion nodes. Later, we're going to see how this works with Besu, how Besu uses Orion for that. But the important thing here is to understand that Orion is the #1 thing that allows us to do that. Okay, now privacy group. The privacy group, as I said, it's almost like a mailing list. So one important thing with the privacy groups is to define the membership information. So who is a member of this privacy group? What nodes belong to a privacy group? If I'm a member of a privacy group, I can send transactions to that privacy group and know that all members on that privacy group will receive that transaction. I don't have to address the transaction one by one, member by member. It makes it a bit easier. And you can see in this diagram here, we've got like an example of two privacy groups. We have privacy group with Bob and Alice as members, and another privacy group with Bob, John, and Mary as members. And this highlights a few interesting concepts around privacy groups. One is that a privacy group, well, a node can be a member of more than one privacy group. In theory, there are no limits on the number of privacy groups that your node can belong at the same time. And the other important thing here is that only members of a privacy group know about the other members of the privacy group. So, for example, in the diagram that we have here, Alice has no way of knowing that Bob belongs to another privacy group with John and Mary. This information is kept private. And this membership information is one of the things that have changed in 1.4, one of our big changes. We're going to talk about it a bit more. Okay, so if you have been using privacy before Besu 1.4, you are familiar with our what we call now off-chain privacy groups. With off-chain privacy groups, the membership information is maintained in a separate database. It just happens to be in Orion, but it has nothing to do with the encrypted transaction database that we have in Orion. Is like second database in Orion. And the way that you interact with the service to create a new transaction is using JSON RPC requests. So there's like a specific method that you call to create a privacy group. When you create a privacy group and specify its members, you cannot change the group. So it's for life. You create a privacy group with 3 members, it's going to have 3 members forever. If you want to add someone to this privacy group, the only option that you had was to create a new privacy group with the previous 3 members and the new member. However, the problem with creating a new privacy group is that you lose history of everything that has happened in the group. So if you have, let's say that you have a smart contract and you want to add a new member, so that member can access that smart contract. With off-chain privacy groups, you cannot do it. You would need to like redeploy the contract and make sure that it's up to date again. So it's not as useful for some use cases. And also the behavior of adding, the behavior for how you create this group is not really easy to change because it's defined in the, it's implemented in the source code of the client. So if someone wanted to customize this behavior, you would need to basically, grab the source, do your changes and compile it again, make sure that, all the nodes are running your latest version. So it's not really easy. With all of that in mind, in Besu 1.4, we are introducing what we call on-chain privacy groups. On-chain privacy groups, they have a few key differences with off-chain privacy groups that we're going to take a look at right now. So for on-chain privacy groups, the membership information, it's not stored in Orion anymore. It's actually stored and maintained by a smart contract. The contract, the group creation and all the management of the group of the privacy group is going to be done using transactions. So now that the group is managed by a contract, you use transactions to interact with that contract, right? And probably one of the most requested features around privacy, now you have the ability of adding and removing new members from the group. And not only that, but new members to a group will have access to all the history of that group. So just to make the contrast with the example that I was using before, if I have a group that has a lot of smart contracts and interactions, when we add someone to that group, this new member will have visibility of everything that has happened in that group. We have access to all the contracts and everything, and we'll be able to interact with those. Another cool thing that comes with the on-chain privacy groups is that because everything is managed by smart contracts, we now have an option of deploying new smart contracts to manage privacy groups that will do things. You can customize the way that things happen. For example, at the moment, our implementation allows any member of a privacy group to add and remove other members. So it's almost like everyone is treated equally. However, as you can imagine, that's not the use case that's going to fit for everyone. Some people don't like that, right? So using smart contracts, you would have the possibility of defining a different behavior. For example, you can have a specific list of admins on a privacy group, and only those participants will be able to add and remove members. Or you can create some kind of voting system where the current members need to approve, a new member to join or a new member to be removed from the privacy group. You can imagine that the options are infinite. And because it's all using smart contracts, it's going to be easier to deploy and replace the previous contract, right? Okay. The other thing that comes with privacy groups is what we call the multiple private world state. It's an isolation of the private state per privacy group. So let's take a step back and look at it, how it works. So in Ethereum, the world state is where all the account and smart contract code is stored, right? All the account data and smart contract code is stored. In a public Ethereum network, every node is going to have one public world state that is, the outcome of all the public transactions. And this public state is the same for every node. Every node has the same public state. For our privacy solution with privacy groups, what we've created is this concept of multiple private states. And each node is going to have one private state for each privacy group that it belongs to. So taking a look at this diagram here, we can see that the nodes to the left have, they all belong to a privacy group A. So they all have the private state A, that is, the private state that corresponds to that privacy group on the database. And the privacy group B, the same thing. They have the private state B in the database. And the node that is in the middle, sitting in the middle, it's actually, because it belongs to both privacy groups, it ends up with two private states, one per privacy group. These private states are completely isolated from each other. And a transaction that is sent to a privacy group A will only be able to affect the private state A. In the same way, transactions to the privacy group B will only be able to affect the private state B. This is like, this isolation makes it easier for, making sure that we won't, I don't know, by mistake affect the wrong private state or anything. So it's good to have this private state isolation. Yep, and again, just a reminder, all nodes still have the public world state that is going to be the same for all of them. Okay, this is probably a good time for pausing for a few more questions. I can see the chat, Grace, so you throw the questions at me and I will get to them.
Yeah, we have a bunch of good ones. First one up, is there a maximum number of privacy groups a node can participate in?
So there's no virtual limit on the number of privacy groups that your node can participate. But as we just saw, because for each privacy group that your node belongs to, you're gonna have a private state. If your privacy groups are super active and you are like sending thousands and thousands of transactions, all of this is gonna require hard drive, right? Like you're gonna require disk space. So as long as you've got, the capability of expanding your disk, you can have as many privacy groups as you want. One important thing here is that the private state, it starts like almost like empty. So belonging to a privacy group doesn't really use that much disk, but as your group has more contracts being deployed and transactions happening, more and more information is going to be stored.
Great. Next one from Mike. How are you managing digital identity overlap in privacy groups? Or is there a self-sovereign labeler to distinguish between two identical usernames?
Okay, so this is a really good question. I forgot to mention the way that we identify members in a privacy group. This hasn't really changed from the previous versions that we had. So when you are using privacy and you set up your node with Orion, we use a public key, the Orion public key, that's going to be used for all the encryption that happens. So we use asymmetric encryption here. So basically every member, every participant is identified by its public key, that is the one that is used by Orion. So in a simple deployment scenario, you're going to have one Besu node, one Orion node, and one key that identifies your participant. You've got options to use multiple keys, so you don't have to use only. And please don't. I'm not talking about Ethereum keys here. So I'm talking about well, I forgot the name. Public and private keys that are going to be used for the encryption of the data. So the way that we identify participants is using their public keys. And I'm not sure that if that answered your question, Mike. Let me know in the chat.
Sounds good. Next question. Who is managing or owning the separate databases for privacy groups?
So the privacy group databases now that they are going to be managed by a smart contract. So what really happens behind the scenes, let's take a peek there, is that when the privacy group is initialized, we initialize that privacy group with the contract deployed inside that privacy group. So the contract that manages the participants actually is deployed inside the privacy group. So this is important because we couldn't have one global smart contract managing that, because we can't share privacy group information with other privacy groups. So we couldn't do that. It's almost like imagine that the privacy group smart contract is part of the genesis of the privacy group. So all the information is going to be stored inside the privacy group private state. Even the group creation is stored there, if that makes sense.
Okay, next one. Julian provided a example to help explain his question, so we'll get there. How does, so I think he's asking how privacy groups apply to token transactions in a Besu consortium network. So for example, he's an investor A, and he wants to privately send a token to an investor B. Does he need to create a privacy group for only one transaction?
So I think there are a few things behind these questions. Let me see if I understand it, if I can explain it. So when you so usually when you are talking about tokens and any kind of thing that you want to share among people, this is only valid if they all have visibility of the number of available things. So available tokens and who owns each number of tokens, right? So when you get to privacy, you would only be able to use like some kind of token contract if you are inside a privacy group. So basically, everyone inside the privacy group will need to have visibility of the balance, of everyone else, and the transactions, like transferring tokens between the different participants and things. So it's not the case that you would have some kind of token contract in the public and use private transactions to privately send tokens to members, but in still consolidating that information in the public. So that's not what you would use restricted private transactions for. I hope that I was able to answer this question. Let me know if I didn't. We can talk more about it at the end if that doesn't make sense.
Looks like you did already, said. Next up, we'll maybe answer 2 or 3 more, and any questions we don't have, we'll bump to the end. Just want to make sure we get to the rest of the content.
Sure.
Next one. Ethereum blockchain can contain data, but we only see transactions. If a company says they are keeping their data in the blockchain, how can one see the details?
Okay, so specifically about private transactions, the actual data is not in the chain. So the private transaction data is going to be sitting encrypted in the Orion database. Orion database is not a blockchain; it's more like a encrypted key value storage. So in the next slide, we're going to see what information about the private transaction we have in the chain. We're going to see what happens, but the actual private transaction data is not stored on chain anywhere. And that's probably one of the key differences between the restricted private transactions from other types of private transactions defined by the EEA, in which the actual content might be transmitted to everyone, even though it can only be accessed by participants. But in this case, the private transaction data is not stored anywhere on chain.
Got it. Let's do 2 more. How are you managing your privacy groups, like creation and management of them? Is that done via smart contracts? I think you already answered this, but just to clarify.
Yeah, it's done by smart contracts, and I mean, it's up how you manage that. It's up to the user, but we've got like the client library that helps interacting with the contracts, because now that you need to send transactions to the contract, it's a bit harder, because if you didn't have the client library, you would need to know how to build the transaction with the specific values and things to interact with those contracts. So, but yeah, it's up to the user. You create the privacy group with an ID, and then the initial list of members, and then from that on, you use the library to add and remove members. So yeah, it's interacting with the smart contract. That's the short answer.
Great. Last one, and then we'll move on. And then we have had a couple of questions about ownership and who controls the nodes, which are in different privacy groups.
Okay, so this is not different from Ethereum. The nodes can, anyone can run a node. The difference here is that when you are creating a privacy group, you can choose what nodes you want to belong to your group. So basically there is a step of, you choose who you want to play with, basically. So if you imagine, there are a couple of different use cases here, but let's imagine the use case where you have this consortium network, and you could choose to, interact privately with just a few of the members, and then you create a privacy group and interact with them. So each member of this consortium network will have ownership of their own nodes and their own Orion nodes and everything. And they just need to decide, who's going to belong to the groups when they are participating. So there's no need for any kind of centralized ownership of the nodes, if that makes sense. So it's basically like Ethereum, and you own your own nodes.
Perfect. We will answer all of your other questions at the end, so definitely don't worry if you haven't answered it yet. But Lucas, let's keep moving.
Awesome.
Great question.
Let's keep moving in. Okay, so we have talked about how the private transactions goes from the sender to all the other participants, and how the list of participants is defined and maintained. So now it's time to actually look at how the magic happens, how the private transaction is going to be processed, and we're going to make sure that all the participants are going to process that private transaction, in the right way, at the right time. To understand that, let's quickly talk about Ethereum precompiled contracts, right? Because one of the key differences, one of the key things here that we did was actually add all of this private transaction logic processing without breaking compatibility with public Ethereum. That was the challenge. We didn't want to change it in a way that would only work for private transactions. We wanted to make sure that it was still compatible with public transactions. So what we did here, if you're familiar with Ethereum, you know that transactions are executed inside the EVM, the Ethereum virtual machine. It basically behaves as like a software implemented computer, which is great for portability, but not really good for performance. So because of that, the Ethereum developers created what they called precompiled contracts, which gives the clients a way of executing native language code when they are processing a transaction, right? Using this concept of precompilers, we saw the opportunity of hooking up some of this logic as almost like as an extension of the regular Ethereum. So we created a privacy precompiled contract that is a piece of Java code that is sitting there waiting to be executed as a Ethereum precompile. The privacy precompile has all the logic that it needs to talk to Orion to retrieve the private transaction and process it, and also all the logic to, after it receives the private transaction, execute the private transaction and apply the result to the private state of that privacy group. So all this logic is implemented inside this precompile. However, we still need a way of calling this precompile, making sure that the client is going to invoke the precompile, and that's where the privacy market transaction, the PMT, plays an important role. So what is the PMT? The PMT is nothing more than a regular Ethereum transaction, public Ethereum transaction. However, it doesn't have anything special, but it's got two really interesting pieces of information that it's gonna be really helpful for processing a private transaction. The first one is the to field. So when you're sending a transaction in Ethereum, the to field is how you can define what's the address of the contract that should receive that message, that should process that transaction when you're interacting with contracts. So in the PMT, we need to make sure that the to field, it's going to be the address of the precompile that the privacy precompile that we want that should be executed. The second piece of information there in the PMT is the data field. So the data field is going to contain a key that is the key that can be used to retrieve the original private transaction from Orion. So remember, Besu is going to use Orion to encrypt and distribute the private transaction to all the participants. And when Orion does so, it gives back to Besu a key that can be used to retrieve that private transaction when you want it back. The private transaction is never stored in Besu, right? This key is like randomly generated. It doesn't have anything. It doesn't leak any information about the original private transaction. In fact, the PMT, by looking at the PMT, you can infer any information about the private transaction. You know that someone did a private transaction, but you don't really know, you don't know what node created the private transaction, what privacy group it belongs to, or what are the contents of that private transaction. I know that it might sound, you're probably asking yourself, wait, so you're saying that we use a public transaction to trigger and process a private transaction? And yeah, that's right. And sometimes people, because of that, people assume that we are leaking information here, but we are not. As I said, all the information in the PMT cannot give you any information from the original private transaction unless you are a member of that privacy group, and then you can use the key to retrieve the private transaction. Basically, the way that it works, when your precompile is going to, when the node is processing the PMT, your Ethereum client is processing the PMT, because of the two fields that points to the precompile, it's going to invoke the precompile, and the precompile is going to use that key to retrieve the original transaction from Orion. Let me go to the next slide. I think it's going to make things easier. We've got a diagram here, and hopefully this is going to help you guys understand where things happen. Okay, so let's go step by step. Someone wants to send a private transaction. So, you create this private transaction to a specific privacy group. Let's say it's privacy group X. This transaction is going to be received by Besu. And the first thing that Besu is going to do is use the privacy group ID X to find the list of participants on that privacy group. With the list of participants in hand, Besu is going to ask Orion to distribute that private transaction to the participants. So, hey Besu, hey Orion, please make sure that this transaction reaches all the participants in this list. Orion's going to do that using encryption in a secure way. When Orion does that, Orion is going to give back to Besu a key that can be used to retrieve that private transaction when you need it. And that's where we get to the create PMT part of the diagram here. With this key, Besu will create this public transaction, the PMT, with the two addresses of the precompile and the key returned by Orion. From that moment onwards, this PMT is going to go through the regular flow of any public Ethereum transaction. It's going to be added to the transaction pool. Eventually, it's going to be mined by someone included in a block and mined. And this block is going to be sent to all nodes in the network. This is regular, Ethereum, how Ethereum works. When the nodes are processing this block, they're going to process all transactions inside the block. And eventually, they're going to get to the PMT, the transaction that is a regular transaction, but it has some really important information for us. When the client is processing the PMT, because the two address is the precompile, the client is going to basically call or precompile and give it all the data associated with the transaction. In our case, the precompile knows that the data is the key that it must use with Orion to retrieve the private transaction. The precompile will then talk to Orion, retrieve the private transaction, and then execute that private transaction against the specific private world state that corresponds to the privacy group that transaction was sent to. So in this case, privacy group X, the precompile is going to make sure that the transaction is going to be executed and applied against private state X. It's important to remember that because the PMT is public, every node is going to be processing it, not only the participant nodes, but also the non-participant nodes. The difference here is that when we get to the precompile, if you are not a participant, remember, Orion makes sure that your transaction only reaches the participants, right? So if you're not a participant, the precompile is going to ask Orion for the private transaction using that key, and Orion is going to return an empty response. It's going to say that transaction doesn't exist. At that moment, the precompile will understand that it's not a member of that private transaction, and we'll just move on. The bottom part of this diagram, the private transaction processing, doesn't happen if you're not a participant. After this process, after all nodes in the network process the PMT, we will know that all the participants will have the private transaction result. Let's say that we are deploying a private contract. They all have the private contract deployed in the private state that corresponds to the privacy group X, and all the non-participants nodes, they will just, they just won't have it, basically. This is the flow of how things, how a private transaction starts and finishes. So again, just to reiterate, one of the key points here is when the precompile talks to Orion, because that's when two things can happen. If you are a member, you find the private transaction, execute it, and update your private state corresponding to the privacy group. If you are not a member, you talk to Orion, you don't find the transaction, and then you just move on. Life continues. Okay, let's pause for a few questions here. I think, Grace, do you have anything for me?
We'll maybe do 3 questions and then move on. First one, any differences on gas usages or costs for private versus public transactions?
So there are a few things here that are probably worth mentioning. So when we are inside private transactions, you wouldn't have, how do I explain it in an easy way? So basically, all the balance information is actually kept as part of the world state, so the world state is what maintains the information about your balance, in your Ether balance. So when it gets to private transactions, because you are inside a private world state, so Ether has no value inside the world state. The gas usage doesn't really make a difference here. So you're not paying. So let me put it in another way. You're not paying for private transaction execution. However, if you are using private transactions in a public network, there is a catch here. You need to remember that because the PMT is a public transaction, you do have to pay to send this public transaction. So there are 2 scenarios here. One scenario, let's say that you have like a consortium network, and then you can basically set your gas price to 0 or whatever. The actual private transaction execution doesn't matter. The public transaction execution, the PMT, probably doesn't matter because you are inside a consortium network. If you are using it on public Ethereum, so let's say that you are running nodes on mainnet and sending private transactions, you won't need to pay any extra for the private transaction execution because that's between the participants of your transaction. However, if you when you are creating the PMT is going to be a public transaction, so you're definitely going to need to pay to execute the PMT. And I hope this answered the question.
Yep. Next question. In the PMT, as a regular public transaction should be signed from the original sender, or this transaction is not signed? So I think the question is whether you can be a signer for private market transactions.
Okay, cool. So there's no requirement on who should sign that private transaction. So one concept that I think it's important to reiterate here is when we are talking about membership and participants, we're talking about nodes. We're not talking about Ethereum accounts. So in reality, it doesn't matter what is the account that is sending the transaction or signing that transaction, signing the private transaction or signing the PMT. In reality, we have got a few different modes of operating in which you can, for your PMTs, you can actually use random Ethereum keys to sign it. So this is a good use case when you don't want to link the PMT to any specific member of your network. So, for every PMT, we're going to basically choose a random key and sign it. There are a few caveats with that approach. Again, if you are using Ethereum on mainnet, for example, you cannot use a random key to sign the PMT because the PMT is going to be a public transaction and you need actual balance to pay for that PMT. Sorry. So there are a few different options. You can also specify like a fixed key that is going to be used for signing your PMTs. And there's also a third option that I didn't mention here. It's kind of a advanced use case in which you can send a private transaction almost like in a 2-step process. So you can first create the private transaction and use Orion to distribute it to the participants, and then create the PMT, create the PMT yourself. So you create the PMT, so Besu won't be creating the PMT, you create the PMT yourself. because if you think about it, the PMT is just like a regular Ethereum transaction. So if you have the address of the precompiler and if you have the key that was used to distribute the private transaction, you can create a PMT, right? So there's like an advanced use case when you'll be creating the PMT manually and signing it. So a couple of different options here. We have a lot of documentation about the different options and when you would use each one of those. And yeah, we can talk a little bit more about it at the end if we have time.
Great. We have a bunch of other really good questions, but I want us to get through the demo first.
Okay.
Again, we will answer all of these, and I'm keeping track at the end of the presentation. So thanks for everyone's patience. Go ahead.
Okay, cool. So let's go to a demo here. So this is a simple demo just to demonstrate this option of like creating an on-chain privacy group and adding someone as a member. What we're gonna see, we have this network with 3 nodes in running. Let's call them Alice, Bob, and Mary. And for each Ethereum node, I have a paired Orion node running. And we're gonna do a few things here. So I'm gonna start creating a privacy group with Alice and Bob and deploy a contract on that privacy group. After doing that, we're going to see that, Alice and Bob can actually access the privacy group, the private contract, and Mary has no clue that that contract exists. After that, I'm going to change the privacy group. So I'm going to add Mary to the privacy group. And after that, we expect that Mary will be able to see the contract because now she's a member of the privacy group. Not only that, but any other interactions in the privacy group, she's going to be able to see it as well. Okay, let me quickly stop sharing for a moment then, and I'll bring things up so we can start. Let me just find myself in the middle of all these windows here. Where is it? There we go. No, not yet. Where did he go? Oh, there you are. Sorry. Okay, I hope you can all see my Postman window. And Grace, would you let me know, is it too small or can we read whatever's here? Like, is it too small or is it good?
Maybe zoom in just a little.
You can make it a bit bigger. Is it better? Okay, let's start. So one thing that I should mention is that please don't worry about, everything that you are seeing here. This is me doing like the things the hard way. So I'm, basically building transactions and sending them myself. I would totally recommend you using one of our client libraries to interact with the on-chain groups. The reason that I'm doing it this way is so you can like basically see the step-by-step process of what's happening behind the scenes, basically. But yeah, so don't get scared. You don't have to do it yourself. I mean, you can do it if you want, but there are easier ways of doing it. Okay, so let me start creating this privacy group again. Because this is on-chain now, I'm going to be sending a transaction and I'm creating the privacy group. And one interesting difference from off-chain to on-chain privacy group is that with on-chain, you choose the privacy group ID yourself. You need to make sure that it's like a randomly generated ID because you definitely don't want to like clashing of IDs or anything like that. So please use a good random generated, like a good seed to generate this random key. If you're using the library, this is going to be done for you, so you don't have to worry about choosing a good privacy group ID. Let me quickly check that this transaction has gone through. So I'm going to use priv get transaction receipt, and then we can see that the transaction has been processed successfully, and we got the privacy group ID here. And we can confirm that the privacy group exists if I use this find privacy group method that is going to give me the privacy group ID, the type on-chain, and the 2 members. And remember, the members are identified by the public key, public Orion key. Okay, so what I'm going to do now, I will deploy a contract on this privacy group. And I'm going to show you guys here, but don't worry. Again, bunch of Ethereum goodness here. And the other thing that I'm using that has nothing to do with our solution is that I'm using this double curly braces here. This basically gives me a way of like replacing a variable in Postman. So it has nothing to do with Ethereum, or there's not like any magic that we did with our request. This is just, this too provides me this option. So I'm going to deploy this contract, and I'm going to use get transaction receipt to make sure that the contract has been deployed successfully. There we go. We got status 1, and then we have the address of the private contract that I have just deployed inside the privacy group with this ID that I'm not gonna read it to you because it's quite long. And to check that this has gone through, let's use priv call, which is like the equivalent of if call, but inside a private world. So with the privacy group ID and the contract address that we have just deployed. And this is a really simple smart contract. It basically stores a value. So we can see that we have initialized that contract with, in it storing a value of 0. You know, this is like I'm calling a getter method in the contract, and it has a value of 0. And we can see that Alice can see that the value. We can see that Bob, because he's a member of the privacy group, he can also see that value, right? 0 here. However, Mary, she's not a member, right? So when she, if she tries to call the privacy group, she gets this empty response. And this is like Ethereum standard response for sending a message to a contract that doesn't exist. So from Mary's point of view, the contract doesn't exist. Okay, so let's go back here and let's add Mary to the group. So I will use this request to add a member to the group. Okay, get a transaction hash, and let me check that this transaction has gone through. No, it hasn't. Of course it hasn't. I forgot a really important step. I knew that was going to happen. So one thing that I forgot to mention is that when you are adding someone to the group, I did that on purpose. No, I didn't. I actually forgot. So when you are, that's why you should use the 2, because that wouldn't happen if you were using the 2. So basically, sorry, the client library. So when you want to add someone to the group, because of this process of bringing that member on board and make sure that this member is going to be up to speed with the current state of the privacy group, we created this concept of locking a privacy group. So basically, that means that if you want to add a member, you need to set your group to a read-only mode. So no new transactions will be accepted on that group, from anyone on that group, unless it's you adding a new member, right? So this is the part that I forgot to show you, but this is the part that if you're using the library, you don't have to worry because it's going to do it for you. So please use the client libraries when you're interacting with this. So I'm going to lock the contract, and let me just check that the contract, the lock. Yep, so the lock has gone through. So now, hopefully, I'll be able to add Mary. Okay. So adding someone behind the scenes is actually like a 2-step process. Okay, good. So you can see that the add now returned a 1, which is like a successful execution. And we can confirm that now when I search for the privacy group based on the ID, we have 3 members, not only 2, right? So adding someone, 2-step process, read-only mode, add member. Remember that if you're doing things the hard way, or use the client libraries and things are going to be easier. And quickly, just to show you guys that I'm not lying to you and that now Mary is a member of the group, let's recap. Alice has access to the contract. Bob has access to the contract. And now, because she's a member of the privacy group, she also has access to the contract. So I know that this demo is like just like a simple demonstration of how this works. But basically, if you imagine what's happening behind the scenes, is that we are making sure that the new member has been brought up to speed with whatever was the latest state of this privacy group. And now the new member has access to any private transaction that has been executed, any contract that has been deployed. So access to the whole history. It's almost like Mary was always a member of that privacy group. Okay, cool. Let me go back to the presentation and we can have some questions about the demo. If I can find the presentation here. Oh, there you go. Okay, so
it doesn't seem we have any. Yeah, it doesn't seem we have any demo specific questions. So maybe let's wrap up with the roadmap, and then if you have any questions on the demo, we'll add it to the queue and
sure,
we'll go through the remaining questions then.
Okay, let's do it. So Now, let's take a look at the privacy roadmap. So this is what you are most likely to see in the coming months. Well, we have 1.4 that has just been released in March. So this is the version that brings on-chain privacy groups with the option of adding and removing members to the groups. And another important feature that is the compatibility with reorg. And this is just like a fancy way of saying that you can use privacy now with any network that doesn't provide a consensus algorithm with finality. Oh, that's even longer. Basically, if you have nodes running on Ropsen or mainnet or any other proof of work based network, now you can use privacy. If you have been using privacy before, you've probably seen in our documentation that we always saying that you should use like IBFT2 or Click or any other consensus algorithm with finality. This is not a requirement anymore. We have just made it available for proof of work as well. This is still in what we call like an early access feature. So we are still seeking for feedback and more people using it. We've got a few nodes running on public networks and everything. So please use it at your own discretion. And we would love to get some feedback on those features. Now, early in June, you're going to get Besu 1.5. And this is going to bring something that has also been super requested from privacy users. That is the option of interacting with logs and creating event filters, log filters for private contracts. So if you are a DEP Ethereum developer, you know that with using filters and monitoring log events is probably the easiest way that you have to interact with a smart contract in your DEP. And so far, we didn't have this functionality implemented for private contracts. So if Besu 1.5, we're going to have logs and filters implemented, and we're going to have our client library updated to support those. And now we get to like more end of the year-ish kind of thing in early 2021, where we do have a few things in our minds of things that we would like to implement. But more important than that, we would really love to hear feedback from the community on those features. And, basically everything that you see to the right is subject to change depending on the feedback and the features that people request. So one thing that I want to ask you is that, make sure that you join our channels, use Besu, use privacy, and let us know what you would like to see in Besu 1.6 plus. Help us, fill the question marks that we have there and make sure that we have things with the right priority when we are working on that. And having said that, I think that's the end of our presentation. I've got a few things to we're going to get your questions, but I believe we have a feedback form in the chat. I think Grace is going to share with you guys there. Please make sure that you fill that feedback form and help us a lot, not only on, to find out what you guys like about these webinars, what you guys don't like, and how we can improve for future webinars. Again, make sure that you download Hyperledger Besu and use it, and break it, do whatever you want, and let us know when it happens so we can improve our solution even more. If you have any questions or anything that you want to talk to us, if you want to reach out and ask for customer support or anything, please contact us at pegasusinfo@consensus.net. Thank you very much for your time, and I hope you guys have enjoyed this presentation. And yep, happy to spend the rest of the webinar answering some of your questions.
So we'll get started with kind of the ones I left off with at the beginning. We had a few questions around, and I know we're up at time. We'll continue going over our time. But if you have to drop, we'll also, as a reminder, be sending the materials and recording out in an email tomorrow morning. So you'll also see it there. First question, we had a couple questions around performance. What is the TPS for privacy groups? How is the performance of private transactions?
Okay, this is not an easy question to answer because every time that we are talking about TPS, we are thinking, it really depends on the use case. So, for example, let me try to put it in a way. So the short answer is using privacy groups doesn't really impact your TPS in terms of, so distributing the transaction and making sure that, it's going to be executed through the PMT. Basically, you are still kind of tied to the TPS of your network, like the public side of your network, correct? because it doesn't matter how many private transactions you have to process, because they are all going to be processed depending on the PMT. So if you don't process if you don't process your public transactions quickly enough, your private transactions are not going to be quick. So basically, there's no private transaction TPS and public transaction TPS, if you know what I mean. Everything is tied to your node TPS, basically. So of course, this depends on your topology and on your network. So if you have like a small consortium network using like a BFT2, you're going to have a really high TPS. If you are using mainnet, you're going to be tied to whatever mainnet TPS is at the moment. So I think the important thing to flag here is that using privacy groups doesn't necessarily increase your TPS, or make it slower. There are a few caveats there. So if you have, let's say that you have a huge privacy group. So, okay, let's say that you have a really good TPS. So you're doing, I don't know, 1,000 transactions per second or whatever in your network. If you have a huge privacy group, the thing that is going to take a long time is to make sure that the 1,000 participants in your privacy group receive the private transaction. So you can't create the PMT until all of them have the private transaction, right? Because, if you have the PMT, but a participant doesn't receive the private transaction, the participant is going to behave as if it didn't have the private transaction, as if it wasn't a member. So if you have huge privacy groups, it's going to take some time to, distribute that private transaction to the groups. But once this is done, the PMT is going to be created and it's going to go through your TPS. So this is maybe a scenario where using privacy and privacy groups might slow your TPS a little bit. But most of the time, and on all the experiments that we have been running, we assume using privacy, you assume basically tied to the network TPS, the overall TPS of the network. Okay.
Great. Next question. Can you explain some use cases for privacy groups?
Use cases for privacy groups. Oh God. I think I can. Let me try to come up with a good one. I've seen so many different use cases that it's hard to think of a good one. But basically, imagine. Well, that's a good one. Let's go with the mainnet one. So, no, not the mainnet one. Imagine that you have some kind of consortium network with, I don't know, between banks or whatever, and they have some process for consolidating the daily balance of the banks. You know how every day banks kind of send money to each other to kind of consolidate the balances and pay the debts with each other. Most of the time, let's say that you have these consortium networks between banks, so each bank is a participant. Most of the time, you wouldn't want every other bank to know about your settlement between each other, right? So you can imagine that, you would want that this settlement happens kind of privately between the members, but at the same time, you might have some regulatory requirement in which a government entity needs to be kind of aware of all the settlements that are happening. So in this scenario, I'm kind of imagining this consortium network with all banks in your country, and then between every 2 banks, you can have a privacy group with the 2 banks and this government entity. So in this way, all the settlement can happen privately between the banks. The government entity will have this oversight of all the settlements that are happening, but the banks don't really need to share the whole information with all banks, the private information between them. That will be kind of a good use case for privacy groups, I guess. I hope this is acceptable as a good use case. I couldn't come up with something better now.
No, I think you covered it well. I think, any kind of private consortium networks, could benefit from privacy groups is the gist, and there are many options that you could use for it. So you're right. Next question is, public smart contract bytecode is stored in world state. Is private contract bytecode stored in private state? And then the second part of that is precompiled contract, the private contract bytecode. You might have
Okay, so first part of the question, yep, private smart contracts, the bytecode is stored in the private word state. So again, if you deploy a contract inside your privacy group X, the bytecode of this contract is going to be stored in the private state corresponding to privacy group X. So yeah, correct. Private smart contract bytecode inside the private state. The second part of the question is about the precompile, right? So I think there are a few misconceptions when we talk about precompiled contracts. So in this case, when I'm talking about precompiles, I'm not talking about bytecode that has been compiled and is deployed somewhere. The name precompiled contract is not great because it can lead to confusion. But what we are saying is that when the client is processing a transaction, instead of executing a contract that has bytecode that's going to be executed inside the EVM, the client is going to execute some native language code. So in our case, because our client is implemented in Java, that means that during the processing of that transaction, eventually our client is going to call some native code, native Java code. So this is what we are calling this is the precompile. So for example, in Ethereum, there are a few precompiles that are used for some of the hashing and crypto calculations that can be quite expensive. And if if you're doing it inside the EVM, they're going to be even more expensive. So this is what I'm referring to. Precompile is basically Ethereum terminology. And I've seen people having the same question. They think about precompiles as some kind of smart contract code that has been compiled. So you have like the bytecode and you use it somewhere. That's not what I mean by precompile when I was talking about it. And I hope this kind of helps clarify the difference.
All right, a few more. You're doing great. No, so first one is, can a private transaction change a public state? I think you answered that.
So if a private transaction can change the public state, no, it cannot.
Yeah.
But there is one thing that you can do. You can actually read the public state from a private transaction. So because the public state is available for everyone, so you can have a private transaction that deploys a contract that somehow reads from the public state, but you cannot in any way affect the public state or affect the private state of other privacy groups with your private transaction.
Great. Next one. Where does the private state reside?
It is inside Besu as a key value database in the same way that the public state is stored inside the client. So if you are familiar with Ethereum, you know how we have, the Merkle trees and blah, 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 yada, yada. I don't want to get into the whole technicality of it, but it is inside the client in the database. If you wanted a bit more details, we've got some details in our documentation, but if I remember correctly, we are using RocksDB as our database implementation by default. So yeah, it's going to be a RocksDB database somewhere in your node.
Cool. Thanks, Darius. Next question. Will the multi-tenancy feature have an impact on privacy?
So that's a really, really, really good question. So the multi-tenancy feature for Besu 1.4, we haven't figured out how multi-tenancy is going to fit with the on-chain privacy. So at the moment, we don't recommend you using it's not really going to work. I think you cannot use it. I'm pretty sure that we forbid you from starting the node with multi-tenancy and on-chain privacy groups. So at the moment, if you need multi-tenancy, you would need to stick to off-chain privacy groups. We are definitely looking at it, and we hope that we might get it done for 1.5. The reason that I didn't put it in the roadmap is because we are still evaluating some of the options, and even if we are evaluating if it makes sense to use multi-tenancy with on-chain privacy groups. So yeah, we're definitely looking into it. So stay tuned, and you might hear from it, anytime soon in Rocket Chat.
Yeah, and I'll drop in the chat. There's some documentation on multi-tenancy in Orion currently.
Yeah.
Next question. How is Besu's privacy different than EY's Nightfall?
Different from what, sorry?
EY's Nightfall implementation?
Well, I'm afraid I won't be able to answer this question because I'm not familiar with what that is. But if you have like, whoever asked this question, if you have a link or something about it, and then I can take a look later, just throw it in the chat and then I can take a look.
Yeah, there's it's their kind of privacy protocol implementation. It's different, but yeah, neither of us are in a good position to speak to them, speak to Nightfall very well. But it's a great question. Next question, and again, we'll just keep going for maybe 5 more minutes. How is Besu's privacy, oops, excuse me, I already did that one. So what if I send a transaction from my dApp that is supposed to generate a private transaction in a privacy group, but also a PMT in the public network? What happens if I don't have gas to write, to unwrite that on the public network? Could I send the private transaction between Orions anyway?
So you're going to be able to, because the whole, so okay, so you're trying to create a private transaction, but you don't have gas to pay for the PMT. You can send the private transaction to Orion, and Orion's going to distribute that to every other participant. As I said, the way that Orion works is off chain, so it's not tied to any kind of gas or anything like that. However, if you don't have enough gas to pay for the PMT, what's going to happen is that the participants are going to receive that private transaction, but it will never be executed. Without the PMT, the transaction never gets executed. So it's not really, it won't be a useful private transaction.
Then I think this might be the last question. I'll have to double check. To decrease TCO, or total cost of ownership, we need the multi-tenancy feature. Well, oh, nope. We already answered that. I heard multi-tenancy cannot go with on-chain privacy group. Yeah. There you go. Never mind. Okay, then looking at the chat, I'll double check if you have any questions that I have not answered. Please feel free to re-drop them in. I could have missed them.
And again, if you don't have a question now, but when you're watching the webinar later, or when you're trying some of the features and you have a question, you can always reach us on Rocket Chat. We have a dedicated channel for Besu there. So, yep, we try to be responsive and help you guys out.
Got one more here. Can we manage the power among users in a privacy group?
So yeah, that's a good question. So as I've mentioned about how we have a flexibility with using on-chain privacy groups, because everything is in a smart contract. So the standard implementation of this smart contract is going to be basically all members are equal. So all members have powers to add and remove new members. However, we expect to see different use cases coming up with different implementations of this smart contract. So in a way that you can have, an admin of a privacy group. So let's say that whoever creates a privacy group is the admin, and it's the only participant that has the power of adding new participants, or something a bit more democratic where there's like a voting mechanism to accept a new member. And we're pretty sure that we're going to start seeing a lot of different use cases and a lot of different implementations of of this. We are looking at providing some other implementations, ourselves as an example, but we also expect to see the community creating different implementations depending on their use cases, and hopefully, they can be reused from by others, and yep, hopefully they're going to be adopted.
Great. It looks like that's the last question. Vijay helped us out and answered the Nightfall question in the chat. So Neil, if you're still looking for that. Great. Then with that, we'll close out. Again, thanks for everyone's time, and please join us next time. Really appreciate it.
Thank you, everyone. Stay safe.